So we want to look at the reaction yield. So the reaction yield will actually tell us how efficient of our reaction was. So ideally, you want the reaction yield to be 100%. 100% meaning that you start with known amount of reactant, and based on the stoichiometry calculation, you know exactly how much product you expect to get. That's the theoretical yield that we just learned how to find out. But let's say then you go to the lab and you do the experiment, and after you recover your product, you don't have exactly the amount that you were after. Let's say you're trying to synthesize, let's say, water. Based on the calculation, I expect to get 2 grams of water. But then when I perform the experiment in the lab, I end up with only 1.5 grams of water. So it means that I don't have exactly the amount of water that I was after. Now, what's important here is to know that the water didn't get lost. If I was expecting 2 grams and I only ended up with 1.5 grams, it doesn't mean that it just disappeared. Because of the law of conservation of mass, no mass is created nor destroyed during a chemical reaction. However, depending on the complexity of your experimental procedure, you may lose some of your product during a chemical reaction. Losing meaning that, let's say, you're filtering your product out and then you don't filter it too well. Or if you have a stepwise reactions, you're not able to recover 100% of the product in each step. So oftentimes when the synthesis or the reactions are complex, involve multi-steps, oftentimes you don't end up with 100%, but reaction yields is a big aspect of chemistry because we don't want to, waste chemicals or throw out chemicals. So if your reaction, you come up with a synthesis, you perform it, and if the percent yield of your experiment is not all that well, that tells you that you need to modify your reaction. So you either modify the experimental procedure or you find a completely different route to synthesize your product in a way that the percent yield is higher. So we're aiming for 100%, but oftentimes it's not possible, but you want your percent yield to be closest to 100%. Now, how do we find the percent yield? In order to find the percent yield, you got to look at your theoretical yield. That's what you expect to get based on the stoichiometry calculation. And you also look at your actual yield. Actual yield is basically your experimental yield. When you perform the experiment, the actual amount that you obtain. And in order to find the percent yield, this is the equation you use. That's the actual yield over the theoretical yield times 100%. So make sure that you memorize this equation for the percent yield. So let's look at example. You want to calculate the percent yield of silver boromide if 375 grams of the compound are prepared from 200 grams of magnesium boromide. So what it's basically telling us is that we use 200 grams of magnesium boromide, and when we did the experiment, we were able to recover 375 grams of silver boromide. So we want to know what's the percent yield. So in order to find the percent yield, we have to find the theoretical yield, meaning that if we use 200 grams of magnesium boromide, how much of silver boromide do we expect to get? So once you know how much you expect to get, you're already given the experimental yield, which is 375, then you can find the percent yield. So in order to find the theoretical yield of silver boromide, you're gonna start with 200 grams of magnesium boromide. So you have 200 grams of magnesium boromide. And I want to know if 200 grams of magnesium bromide is used, how much of silver bromide do I expect to get? So we convert this to moles first. So each mole magnesium bromide is 184.1 grams of magnesium bromide. And then based on the balanced reaction, each mole magnesium bromide produces 2 moles of silver bromide. And in order to get the mass of silver bromide, we need to use the molar mass of silver bromide. So 1 mole silver bromide is 187.8 grams of silver bromide. Now, what this tells me is that using 200 grams of magnesium bromide, I would expect to get 408 grams of silver bromide. So 408 grams of silver bromide, that's the theoretical yield. Now, to find the percent yield, that's our actual yield, which is 375 grams, divided by theoretical yield times 100, which is 91.91%, which is a good percent yield. So let's look at another example. You want to calculate the percent yield of aluminum oxide if 125 grams of aluminum gives 100 grams of aluminum oxide. So the initial quantity of aluminum used is 125 grams. The amount of aluminum oxide that was recovered was 100 grams, but you want to know what's the percent yield. So to find the percent yield, we have to know the theoretical yield. Theoretical yield is the expected amount of aluminum oxide. So if we use 125 grams of aluminum, we want to know what's the maximum amount of aluminum oxide that we expect to get. So each mole aluminum is 26.98 grams of aluminum. And then based on the balanced reaction, each 2 moles aluminum gives us 1 mole aluminum oxide. And then to convert to mass, each mole aluminum oxide is 102.0 grams of aluminum oxide, which is 236.3 grams of aluminum oxide. So this is the theoretical yield of aluminum oxide. To find the percent yield, percent yield is the actual or experimental yield, which is 100 grams, divided by theoretical yield, which is 236.3 grams, times 100, which is 42.32%.